So let's talk about Squeeze theorem. What's Squeeze theorem? Do you understand Squeeze theorem, by the way?
Has something to do with one function b.
Yeah, there's one function being between two functions, yes. All right, now, so let me give you an analogy. Now, how accurate is this an analogy? Well, please make it accurate. All right, no, actually not a house. Who would like to go home? So, and do you all still go to mall nowadays? Like go to First Colony Mall? Okay, all right, so still a thing? So let's just say it's called ABC Mall, all right? Um, so get some pretzels, all right? Now, and you happen to have two siblings. One is older than you. Let's just say you have an older sister, okay? You have an older sister. And you also have a younger brother, okay? So you ask him, you say, hey, sister, where do you want to go? Your sister says, well, I'm going to the mall. And your brother says, oh, you ask your brother, and your brother says, oh, I'm going to the mall as well. So where would you go? Okay, now, of course, you can make an argument. I don't have to go with them, but for the sake of this analogy, because they're all going to the mall, so you don't really have a choice. You're the one in the middle. You have to follow both of them. So you are going to the mall as well. So that's basically the idea. If the bigger function and the smaller function, they're all heading to the same destination, then the intermediate function, the middle one, has got to go to the same destination, period. Okay? So let me go ahead and give you one example. I believe this is an example from your handout as well. I think it's at the bottom of your one of your handouts. I forgot which one it was, but it looks something like this. Okay? It says, hey, you have this relationship right here for all values of x except 0. So can you go ahead and find out limit as x approaches 0 for f of x? What would that be? So whenever you see this setup, it is 10 times out of 10, 100% squeeze theorem. So if you understood what the analogy is all about, so where are we going? Well, x going to 0. So we say, hey, let's go ahead and investigate on the smallest function. Where would it go if x goes to 0? It's 4. How about the bigger function? Well, as x goes to 0 for 4 plus x squared, where would it be? It's 4. So since the bigger function and the smaller function are both going to 4 as x approaches 0, therefore, f of x would have no choice but to go to 4 as well. Okay? So this is one type of squeeze theorem examples of problems that you will see. But what I would like to show you is another kind of squeeze theorem problem. Okay? And that would be something like this. You see, where is it? Squeeze theorem. Now, when you see squeeze theorem, it's quite likely that you might see some sort of trig functions involved. So let me see where that is. Okay, here we go. So limit as x approaches infinity for cosine square x over 3 minus 2x. Okay? So now, if you say, well, how am I supposed to do this? Because if I plug in infinity, well, it's not like the situations earlier. We can't really just divide by the greatest power. So what do? Well, the reason why I said that you are likely going to see some trig functions, especially sine and cosine, is because they have boundaries. So think about this. What's the upper bound and lower bound for cosine of x? Cosine of x could go as high as and as low as, but cosine squared, what about cosine squared? As high as and as low as? Not -1. Not 1. I mean, 1 is the highest, the higher bound. 0. So that's why we can now establish a relationship, and that is, well, 3 minus 2x has got to be between two functions. Which two? Well, cosine square of x could be as great as 1. So 1 over 3 minus 2x. And cosine square x could be as small as 0. So 0 over 3 minus 2x, which is 0. So then we say, oh yeah, that will be the relationship. You have to create this relationship to continue the discussion using Squeeze theorem. And then we say, oh, okay, let's go ahead and find the limit for the smallest function and the biggest function. And what do we find out? They're both heading 0. They're both heading 0. So guess what? What is the limit of cosine square x over 3 minus 2x? It's got to be 0. It has to be 0. So this is a way to find out limits indirectly, because we have no way to directly assess what this limit would be by plugging in infinity. There's no way to simplify this algebraically, but we can use the boundaries to predict its behavior. And since the behavior of the bigger function and the smaller function would both go to 0, and since they serve as the boundaries of this rational function, so cosine square x over 3 minus 2x, it has got to go to 0. Now, let me go ahead and show you something. 1 minus y equals to 1 over 3 minus 2x. And then y equals to cosine of x squared divided by 3 minus 2x. And then, of course, we have y equal to 0. Okay, so let me go ahead and amplify the graph, -1 and 1. So just to show you how the graph it's going to be like. I hope this can show you the boundaries more vividly. The blue line, it's the 1 over 3 minus 2x. The green line, it's just y equal to 0. The blue line, it's the cosine square x over 3 minus 2x. So that's what I mean by boundaries. The middle function, it's bounded by those two lines. So that's why it has to go to 0. Okay?